The hard disk drive, commonly called hard disk, hard drive, or simply HDD, is a long-term storage device that stores data on a metal disk called platter. The platter is coated with a magnetic material which is magnetized while spinning at a high speed by an electromagnetic head that hovers just above its surface. To write data to the disk, the head is powered by electricity to create a magnetic field, which magnetizes tiny sections of the platter in one of two directions, representing bits as either 1 or 0. The magnetic head can also reverse the process, converting the magnetic fields on the platter back into electrical signals to read the stored information. Larger capacity hard drives might feature multiple platters and magnetic heads. Hard drives have been used to store data in personal computers for more than 60 years, and thanks to the advancement in technology, they have become smaller, faster, quieter, and more energy efficient. Additionally, they are still around twice as cheap as the most affordable SSDs on the market for the same capacity. The most notable standard sizes for hard drives include 5.25 inch, an all-standard, although base of this size can still be found in some PC cases. Mounting adapters called hard drive caddies can be used to fit smaller drives into this base. 3.5 inch, commonly used in desktops, workstations, and servers, and 2.5 inch, typically used in laptops and smaller desktop computers. However, it should be mentioned that most modern laptops no longer use hard drives as their size and weight made them unsuitable for thin and lightweight devices. By their connector type, hard drives are divided into several categories. Parallel ATA, also called IDE or ATA 133. This is an older standard that uses white ribbon cables for data transfer and a Molex connector for power. Unlike other areas of electronics where parallel interfaces are typically faster, in computer storage they are slower than serial ones due to signal interference and limitations in scalability. Serial ATA or SATA, still widely used today. SATA provides significantly higher speeds than PATA and uses much smaller connectors for both data and power. Its design also improves airflow in computer cases and allows for longer cable lengths to be used, making it a preferred choice for consumer-grade hard drives. SCSI, also called Parallel SCSI and pronounced SCSI. This interface is commonly used in enterprise servers and workstations. It supports simultaneous read and write operations, allowing for higher true output compared to consumer drives. SCSI drives can handle multiple users on the same bus and are built to be more robust and reliable. SAS, the serial version of SCSI. SAS offers even higher transfer speeds, smaller and more compact connectors. It retains and improves the enterprise-grade features of SCSI, such as multi-user support and enhanced durability. The speed of a hard drive depends primarily on the rotational speed of its disk, measured in revolutions per minute. Consumer-grade hard drives typically spin at 5400 or 7200 RPM, while enterprise-grade hard drives often use higher speeds of 10,000 or 15,000 RPM for faster performance. However, rotational speed is not the only factor affecting the overall speed. The interface used for data transfer also plays a significant role, with performance varying by the interface version. The latest PATA version supports speeds up to 133 MB per second, while the third SATA revision offers speeds up to 600 MB per second. SCSI supports up to 320 MB per second, while SAS provides effective speeds up to 1.2 GB per second. You might see higher maximum speeds listed for serial interfaces, but these also include the extra bits used for encoding along with the information bits. It is important to note that hard drives usually don't reach the maximum speeds of their interfaces due to mechanical limitations. Typical sustained transfer speeds for HDDs range from 80 to 220 MB per second, depending on the drive specifications. Additionally, every hard drive has a buffer made of dynamic RAM, which is also called hard drive cache. Usually, more cache means better performance as it helps the drive handle more data efficiently. HDDs offer several advantages. Primarily, their large storage capacity at a relatively low cost. They are widely available in sizes ranging from 500 GB up to 32 TB, making them particularly beneficial for users requiring high volume storage. Additionally, HDDs are reliable long-term storage, with many models designed for continuous operation. Furthermore, the method used for storing the information allows for easier data retrieval by using specific software for restoring permanently deleted files or by using other techniques in case of hardware failure. This makes HDDs a preferred solution for storing important data for many users. However, they have several drawbacks. First, they are susceptible to mechanical failure due to their moving parts. Second, the read-write head can wear out or be damaged by shocks or drops. It is flying just a few nanometers above the surface of the disk, and if it hits the surface, it will result in catastrophic failure and guaranteed data loss. This is why you should always hibernate or shut down a laptop with an HDD before carrying it. Third, HDDs are sensitive to temperature changes and vibrations, which can affect the performance and reliability. Compared to SSDs, they consume more power, generate more heat, and have a lower maximum operating temperature. Additionally, fragmentation can lead to slower read and write speeds. Fragmentation occurs when files are broken into pieces and spread across different areas of the disk. This happens over time as files are created, modified, and deleted, leaving gaps between the pieces of data. As a result, the read-write head must move more to access the fragmented data, which can slow down the overall performance of the hard drive. To avoid such case, Windows 10 and later versions include automatic weekly defragmentation scheduled by default. In older versions, defragmentation must be run manually to maintain the performance. When selecting an HDD, consider the capacity, RPM, cache size, and brand reputation. Choose a capacity that matches your storage needs. Drives with 7200 RPM generally offer better performance than the 5400 RPM models, but casual users don't need 10,000 or 15,000 RPM drives. These high-speed drives, commonly using SAS interfaces, prioritize reliability and durability for enterprise use, but come at a high cost comparable to PCI Express Gen 5 SSDs, and don't provide significant benefits for the general user. Look for a larger cache to improve data transfer and select well-known brands such as Seagate, Western Digital, and Toshiba. If unsure, seek advice on PC forums. I hope this video was helpful. Please give it a thumbs up and consider subscribing if you want to see more videos like this. Also, feel free to leave a comment below. Thank you for watching and see you soon.